Welcome to lecture number 31 for ECE 476, Advanced Embedded Systems. In this lecture, we're going to give a couple examples of stuff you can do with the Bluetooth interface. Now, in the previous video, we looked at connecting your Pico to a Bluetooth interface. In this case, I'm using the serial Bluetooth app on my cell phone. If I connect to my Pico, I can make an LED turn on and off. That was our last lecture. In this lecture, we're going to add some features, such as I can now send commands. Like if this is the brightness I want for my LED light, I'll connect, then send the command. I can turn on the LED lights. I can make them dimmer. I can turn them off. I can send more complicated commands, such as I can tell the red, green, blue what the level should be. I can send individual commands, such as I want the green light to be 30. I want the blue light to be 100. And I want to write that, turn on the lights at that setting. Finally, I can build a strobe light. I can set the on time to be 10 milliseconds. I can set the off time to be 990 milliseconds. And then go. So those are some of the things we can do with Bluetooth interface. In this lecture, we'll look at how you do that. So starting out, the app I'm using on my cell phone is the Serial Bluetooth Terminal by Kai Morash. This is a free app on your cell phone that sends and receives serial data to your Pico. In addition, I need some drivers for the Pico. These need to be located on your Raspberry Pi Pico itself. So in Thani, you should be able to find BLE Advertising, BLE Simple Peripheral. Now, if you don't have those are on Bison Academy. So you can get those or refer to lecture 30 for more details on that. So let's start out. In the previous lecture, we had the basic code for receiving data using Bluetooth. So I include the Bluetooth module, include BLE Simple Peripheral. I then set up a Bluetooth interface and then set up a serial port, Bluetooth serial port. What this one does, this just toggles LED 0. The way this works is it constantly polls, checks the serial port. If you're connected, I will send data at any time I receive it. If the data happened to be LED 0, it's going to toggle the light. So what that kind of looks like, if I run this, over here I've got to connect to the Bluetooth. Once I'm connected, I can then send the command LED 0. So LED 0, send it. And you can see the LED light. You can't see the LED light. There you can see the LED light just turned on. If I send it again, LED light turns off. So that's the basic code from the previous lecture that we're going to be building upon. Let's build on that. Instead of just turning on a single LED, let's drive the NeoPixel. I want to have the NeoPixel act as a flashlight. I can set the brightness anywhere between 0 and 255. Now to do that, I need to first figure out how to drive the NeoPixel. There are several ways to drive a NeoPixel. One of them is you can use the bitstream. You can use the NeoPixel app that's part of Thani. You can use a PIO state machine, an upcoming lecture. Here I'm going to be using the NeoPixel driver. It doesn't work on the NeoPixel on the Pico because the timing's off, but it does work on the NeoPixel that I got off of Amazon. So I'm just going to use that one. So the base code to turn on a NeoPixel is as follows. I'm going to import NeoPixel. I'll set up an instance of NeoPixel on pin 1 over here. I've got 16 lights attached to it, and so this initializes it. If I want the lights to be 1, 2, 0, 1, 2, right, then I get all the lights turning on with this brightness. So that's the base code. Now I'm going to build on that. Let's let you vary the brightness based upon data from the Bluetooth interface. So when I do that, I've got to send a message, and this is really up to you, the programmer. What does the format of the message look like? Now, I used to work with a company that had a mandate back in 2000. They required all messages to be in ASCII. It's not quite as efficient, but the problem with binary data is that if you lose the instruction manual, you have no idea what's going on. At least in ASCII, you've got a shot. And if the programmer is really nice, they'll set it up so if I send something like help or question mark, you'll get back the instruction manual for those days when you or that eventual day when you lose the instruction manual. So I'm going to assume ASCII interface. Let's assume the data that I send is 3 digits, 000 to 255. And this is what I call programmer-friendly software. I can't send the number 0. It's got to be 3 digits, 000. With a little bit of programming, I could make it 23 rather than 023. But I'm not that motivated right now. So I'm just going to assume I have to send 3 digits, and the digits have to be between 000 and 255. Again, I call this programmer-friendly software. If you follow the instructions, it works. If you don't, no guarantees. Next, what I'm going to do is when I receive data, this is the on Bluetooth receive. Here's the data that came in. That'll be a text string. I'll print out the text string and then check if the first 3 digits are a valid integer. I will receive it, clip it at 255, just in case somebody typed in 999. Set the flag. Flag equals 1. Otherwise, say invalid data. Kind of note that here I'm using global variables to pass data. This is kind of acts like an interrupt service routine. It's not, but it sure looks like one. The only way to pass data to and from it is through globals. Now what the main routine is going to do is check. It's going to say if you're connected, send whatever data you received to the on routine, on Rx, and then check if the flag was set in the background, meaning it just received data and the flag was set. I will print on the console the brightness level. I will set the brightness of red, green, blue at the same level. That creates a white light with purple brightness. Write it, and then write to the LCD display the current brightness levels, and clear the flag. So here's what that looks like. So I just started the program. It's currently looking for a connection. I'm now connected. It wants a number, so type in 012, send it. Now the brightness level is 12, but send the number 255. It takes it 5, make it dimmer. And if I do something nonsense like QWER, send that. The program doesn't crash, but what happens is they get an invalid data entry. Back in the shell window, I can see what the data as it comes in. So again, let's type in the number 123, send. I just received the binary string 123 character return line feed. All the program looks at is the first 3 characters, and that tells you the brightness. What it does not accept, I can't say the brightness level should be 6. Again, that's kind of a nonsense answer. Well, maybe I can do that. I didn't think this was going to work. 35. Yeah, I guess it did work. All right. Surprisingly. You can type in the number, and then it takes it. I didn't think that would work because it takes the first 3 characters. Apparently, the integer ignores character return line feed. Something I didn't know before. Okay, anyway, so I can now use Bluetooth to control the brightness and level of a flashlight. And as I just showed, the shell window displays debug information, such as I've got a connection, here's the data that I received, and here's the brightness level, how I interpreted the data that you sent. Okay, so that's the first program. Now, with this program, all the LEDs are the same brightness level. Suppose instead I wanted to vary the brightness. I want to be able to specify red, green, blue separately. Now, there's a couple ways of doing this. One of the challenges I have to figure out how I'm going to format the data. I'm going to send a text string to the Pico. What is the format of that text string? How do I interpret it? There's many ways of doing that. So what I'm going to assume is that the message is in the form of red, green, blue. All these are 3 digits. In the receive routine, I can then parse the data. The red level is always these 3 digits. The green level is always here, and the blue level. And if you notice, I don't really care what these characters are. It could be ZZZ. Art, it's ignoring it. The field has to be red, green, blue, though. If I switch the order, make that blue, green, red, it's still going to interpret it. First field is red, green, blue. Once I pull that out, I'll then fill the array for the NeoPixel with those brightness levels and write them. So all the LEDs are the same brightness set by red, green, blue. Again, once I write it, I'll set a flag. And then what the main routine does is it just checks whenever the serial data is received, send it to the onRx routine. And then if the flag is set, write to the LCD display. Note again that I'm using global variables. This behaves like an interrupt service routine, so about the only way to pass data to and from it is through globals. So what that looks like is as follows. I'll go over to Flashlight version 2, run that puppy. Now this is currently the brightness level. I have to send a string, like let's do red 000, green 050, blue 020. Send. Oops, I gotta connect first. Connect. Then send. And there's the color. Let's change that to pure green. Let's add a little bit of red to it. Green 010, blue 000. Got an orange light. Once again, in the shell window, when I send data, it tells me this is the data that I received. Here's how I parsed it. I interpreted that data to be red, green, blue, and then set the brightness levels. Note in this case that I cannot shortcut. Like I can't say red 0, green 5, blue 6. Send that. That's an invalid entry because it looked for this field to be red, and that's not a valid number. So in that case, the exception kicked in where I just told myself the data that input is invalid. It's got to be in this format. In addition, I'm actually ignoring the red, green, blue RGB. I can just do X005, X200, X030, and it'll take it. I'll also just do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. do all zeros, it'll take that as well. So that's our second program. I can vary the brightness of the NeoPixels. Third program, Flashlight 3, kind of sets a programming language. Instead of having to send one big long command that has all the information in it, another way to send data to it is to set up a set of instructions. So let's have 5 instructions. I'll specify the red color, green color, blue color. Clear, just a convenient way to do 0, 0, 0. And write. Every time I hit write, the NeoPixels are updated. So this is just a different style of setting up the commands. In terms of the receive routine, I'm going to pull in the first character, that's my command, and then check. If the command was red, I'll interpret the next field as the red brightness. G is green, B is blue, C is clear everything out, and W is a write. In addition, I also need flag equals 1. And all these are passed as global variables. In the main routine then, I'll just turn on the serial port interface. If I receive data, ship it to the on Bluetooth receive routine. If the flag is set, then update the display. So here's what that looks like. I'll first go over here. Oops. Run Flashlight version 3. I need to connect to the Bluetooth interface. I'm not connected. I know I can use my commands. So let's do R040. Send that command. That updated the light to 40. The NeoPixels haven't been turned on yet because I need to execute a write command to do that. So let's do a write. So there, red is 40. Let's do green, 020. And let's write that. And let's do blue, 010. Write that. Clear the lights. Clear, write, turns the lights off. So there I kind of have a programming language. I've got a set of commands. What I probably should do is throw in an extra option, a question mark, or H for help. If I see a question mark or an H, then I would have a print out the instruction manual for those of you that forget what the correct commands are. Or in this case, if I have an invalid entry, like let's do an X. Yes, I took that. Invalid entry. It'll tell me what the commands are. And again, the shell window is just for debug information. Finally, let's build a strobe light. Now there's a couple ways to do a strobe light or to specify it. What I'm going to do is assume I'm going to specify the on time in milliseconds, the off time in milliseconds, and I can turn the strobe light on and off. So there's really just 4 commands. I'll also assume that all 16 NeoPixels are the same brightness level, and they vary from 0 to 255. Now there's a couple ways to keep track of time. Since this is a strobe light and timing is kind of important, I'm going to be using interrupts. So again, I'm going to have one interrupt for turning the lights on. This is going to be one shot. Every time it executes, it sets up the off time. The period is T on, so when I call the light on, the light turns on for T on, milliseconds. The callback routine is light off, and I turn the lights fully on. T on seconds later, this routine kicks in. That turns off the lights, sets up a one-shot interrupt in the future, T off seconds in the future, and repeats. The way I turn this off, there's a couple ways to turn it off. Here I've got a global variable called status. If status is 0, then I don't turn it on again. And so if this never happens, the strobe light stops running. What I could also do is just run a deinitialize command. That'll also turn off the interrupts. So either one works. I chose to use status. For the on routine, I'm going to assume I've got 4 commands. N for on, F for off, G for go, and S for stop. The on and off commands need to be followed by 3 digits. That's the on time and off time in milliseconds. And then G and S are just G and S. To implement that, I'm going to again pass data through global variables. And I forgot to set flag equals 1 right here. If I receive data, I'll then pull out the first digit to see what it was. If it was an on command, T-on is the next 3 digits. Off command, T-off is the next 3 digits. A go, I'll set status to 1, and then start the strobe light. If it was a stop, I'll set status to 0. Then the main routine, it just sends data to the interrupt service routine anytime data is received. If the flag is set, meaning just received data, update the LCD display and clear the flag. So here's what that looks like. If I go to the strobe light, turn that on, I can now set the on time. Just have to connect. I'll set the on time. Let's do that for 100 milliseconds. Let's set the off time for 900 milliseconds. And then go. So there's my strobe light. I can stop it. And let's change the on time to, I'm not sure this is going to work. Let's try on for 10. I took it. Okay. Try the off time for 990. Go. And here's not showing up on the monitor just because of aliasing. Let's stop that. I have to have the on time long enough that the camera can pick it up. Let's try just for fun. Let's make the off time 90. Start. Oh. Go. Again, in person, this is flashing at 10 Hertz. On the camera, it depends upon the frame rate. The camera has a hard time picking this up. Stop. What I'm seeing is aliasing with the camera. The camera isn't sampling fast enough to pick up a 10 Hertz strobe light. So I can also set up a starter tree. So let's set the time between lights to be 500 milliseconds. And then for my cell phone, I'll tell the starter tree to go. That starts turning on the lights every half second. Once all the lights are turned on, they turn green. The race is going. I can then clear the lights and start a new race. Let's make this one T1000. 1 second between lights. On your marks. Oh. We'll start the race. Go. Lights are turning on one at a time, once every second. Once all 16 lights are turned on, it's time to go. So these are all things you can do with a Bluetooth interface. There's many other things as well. It's kind of limited to the creativity of the programmer. By using the libraries BLE Advertising and BLE Simple Peripheral, you're able to send data from your cell phone to your Pico. With a little bit of coding, some different commands can be sent to the Pico controlling its operation, such as the brightness, color, or flashing rate of a NeoPixel. You can also send other commands. The commands that you can send are really only limited by the imagination of the programmer. But now with Bluetooth, I can control stuff through your cell phone. And I think that's pretty darn neat. That's one of the things that I find really impressive with the Pico. It really opens up possibilities for what you can do. That's lecture number 31 for ECE 476.